All my life I've wondered about life beyond the Earth. On those countless other planets that we think circle other suns, is there also life? Might the beings of other worlds resemble us? Or would they be astonishingly different? What would they be made of? In the vast Milky Way galaxy, how common is what we call life? The nature of life on Earth and the quest for life elsewhere are the two sides of the same question, the search for who we are. All living things on Earth are made of organic molecules, a complex microscopic architecture built around atoms of carbon. In the great dark between the stars, there also are organic molecules in immense clouds of gas and dust, simplest forms. And on some small fraction of worlds, there may develop intelligences and civilizations more advanced than ours. All life on our planet is closely related. We have a common organic chemistry and a common evolutionary heritage, and so our biologists are profoundly limited. They study a single biology, one lonely theme in the music of life. Is it the only voice for thousands of light years? Or is there a cosmic fugue, a billion different voices playing the life music of the galaxy?
It was during the early decades of the 19th century that the structure of atoms was coming into focus. It was known, for example, that a hydrogen atom contained one proton and one electron. But the scientists of the time could think of no stable arrangement of the two particles. It was known that a proton and any atom were grouped in a small central region called the nucleus, and that the electrons were somehow arranged in comparatively large distances outside the nucleus. But in hydrogen, if the electron were stationary, it would fall into the nucleus, since the charges on the particles would cause them to attract one another. Yet the electron couldn't be in orbit circling the nucleus either. Circular motion requires consistent acceleration of circling body to keep it from flying away. But the electron has charge, and charged particles radiate light when they are accelerating. So an electron in a circular orbit would radiate light and would spiral into the nucleus. And Bohr simply dismissed the problem of an electron radiating away its energy by stating that it just didn't happen. Even great scientists cheat sometimes. He postulated that inside an atom, electrons only radiate energy when they jump from one allowable orbit to another. And the energy of this radiation reveals the allowable orbits. The wavelengths of light absorbed by hydrogen when white light is shined upon it, as well as the wavelengths of light when it is subsequently re-radiated, had been precisely studied at the time but never explained. Here's a sample of an absorption spectrum and an emission spectrum. By predicting the value of orbits that an electron could have, Bohr's model also predicted the wavelengths of the lines in the hydrogen spectrum. And his model was tremendously successful. It explained in exquisite detail the atomic spectra of hydrogen. When the energy of the wavelengths of the spectral lines are compared to the energy differences in orbits allowed in Bohr's atom, they agree exactly. So the quantum approach worked well in explaining the allowable orbits. But no one was certain why only those orbits were allowed. since Einstein and Planck and Compton had firmly established that light could have the characteristics of both a wave and a particle, Du Bois suggested that matter particles, protons, electrons, atoms, billiard balls, could sometimes act like waves. And when this idea was applied to Bohr's atom, it answered many questions.
All electromagnetic radiation is light. Visible light is the only part of the spectrum you can see. For all your life, your eyes have relied on this one narrow band of EM radiation to gather information about your world. Though our sun's visible light appears white, it is really the combined light of the individual rainbow colors with wavelengths ranging from violet at 380 nanometers to red at 700 nanometers. Atmosphere by considering how atmospheric particles scatter visible light. Earth's atmosphere, for example, generally looks blue because it contains particles of nitrogen and oxygen which are just the right size to scatter energy with the wavelength of blue light. When the sun is low in the sky, however, light travels through more of the atmosphere and more blue light is scattered out of the beam of sunlight before it reaches your eyes. Only the longer red and yellow wavelengths are able to pass through, often creating breathtaking sunsets. Our sun produces more yellow light than any other color because of its surface temperature. If the sun's surface were cooler, say 3,000 degrees Celsius, it would look reddish, like the stars Antares and Betelgeuse. If the sun were hotter, say 12,000 degrees Celsius, it would look blue, like the star Rigel. Like all parts of the electromagnetic spectrum, visible light data can also help scientists study changes on Earth, such as assessing damage from a volcanic eruption.
Journey deep and wide, within and outward. Imagine all space and time your playground. Engaging the infinite aspects of limits emerging. The light, always the wondrous light, shines forward. Activate, activate, activate. Initiate, initiate, initiate.
According to therapist Frank Perry, they can help you relax and balance your energy flow. And here he is again, Glenn Farrell, who's been getting teased mercilessly at work, I gather. He's back to try this out. But thank you very much for coming. Frank, this all looks rather sort of weird, magical and a bit hippie. So try and explain in the short time you've got what this can do. What can it do for people when they come along to you?
Well, basically, it's also concerned with self-knowledge and self-development. So the fundamental thing is when they strike these sounds, they really go on for a long time. So they would meditate on listening to the sound, and a yin and yang, finishing with a yang bowl.
Can anybody do this? I mean, there's no danger to anybody.
On repeat, yeah.
I gather that it's been causing something of a stir that Glenn has been volunteering to do these. Goodness knows what they're going to say about this, but you found some good in it.
Yeah.
Leave us with one of these beautiful noises, will you, Frank? Thank you very much. Sadly, time has beaten us again, but do join us again tomorrow.